Okay, welcome back to another video. So, what are we doing today? We will be getting to the basics of Arduino starting from breadboard. Okay, what I have here is a solderless breadboard, which is a very versatile platform when you're beginning to start with Arduino tutorials or any kind of electronic assembly. Now, all the breadboard have this line of symmetry, which is pretty common. These rails on either side of the breadboard are called the bus rails, and the way this one works is when you power any one terminal. Take for example, if you power this terminal, right, you will be powering the entire column of the positive bus, and if you power any one of the terminals in the negative line of the bus, you will be powering its respective column. So remember, the bus rails on either side of the breadboard are powered column wise, whereas every other thing except those are powered row wise. Okay, so here is the actual work area. You'll be connecting the Arduino processor or any sort of analog output device over here. So if you power any one terminal over here, you will be powering the entire row before the line of symmetry. So this line indicates that there is no connection between this row and this row, right? So you'll be powering alpha 1 till echo 1, and you will not be powering foxtrot to Juliet. There is no connection between rows, so row 1 and row 2 are completely independent, so you don't have to worry about loose connections going to row 2 from row 1. So that doesn't happen in this breadboard. The reason being is this: if you flip the breadboard upside down, this is what you will be able to see. As I mentioned, in the bus rails, the reason why you will be powering in columns is because of this power line leading the way. And the reason I told you you'll be powering in rows in the actual work area on the breadboard is because of this. This is one row, this is another row, and there is no connection between the rows, as you see. I have an LED, a resistor, a push button, a battery, and obviously the breadboard. So we are going to be building the circuit on the screen right now using a breadboard. First of all, we're going to hook up the LED to two different terminals. So as I mentioned, you're not gonna have it this way, because if you do it this way, then this is what you'll be doing in practical situation. You're just gonna connect two terminals to just one wire. Whereas if you hook it up this way, you can have two different terminals leading to two different nodes of the LED. Just see where the positive lead and the negative lead is going to avoid confusion. So right now I'm going to plug the negative lead of the LED to pin 30 and the positive lead to pin 35. Okay, so to avoid the LED from burning out, we will be using a resistor. You can actually connect the resistor anywhere you want to, right? So I'm doing it this way because now you're connecting the LED to this part. Now you can actually use a push button to put it next to the resistor's pin, because putting it here, you're actually not completing the circuit. So we'll be putting the push button somewhere here, but make sure one of the terminals is aligned with the resistor's terminal to avoid any kind of difficulties during testing. Let's just take the batteries and connect it to the place that we actually want to. I'm putting it there, and this one is going there. Okay, pressing the button will actually make the LED glow. Now that's a very simple circuit we got there. Okay, with that being done, we have to be familiar with two terms: analog and digital. Well, analog are just physical quantities such as force, voltage, etc. Well, digital is just a conversion of analog in the form of ones and zeros. It's called the low-level language that the computer can understand. Example of analog input, analog output. The circuit we built before could be the best example for that. So the analog input, you have the push button, and the LED stands for the analog output. So when you push the button, the analog input is converted to an analog output, as the LED is an analog output device. Analog input, digital output. Well, for those console gamers out there, you might be familiar with this joystick module. Well, this is a pretty basic and an essential component of the controller. And when you're pushing the joystick to its position, the character in the gaming world moves in that designated direction, and that's the best example of the conversion from analog input to digital output. Digital input to analog output. Well, in this case, for those of you who missed out the previous video, please go and check it out. It's an amazing video. The link is down in the description because I'm going to use that as an example right now. Well, in the previous video, we hooked up an LED strip to Arduino and Bluetooth module and we controlled it through our mobile phone. Well, in this case, we are sending Bluetooth signals from our mobile phone, which are basically digital signals, and we are getting an analog response from LED. Now, this is the last example, digital input to digital output. Well, imagine I'm playing piano or a keyboard which is connected to a system or a computer that has a graph that determines the pitch of every single note. Okay, so if I'm going to press key 1, there's a particular pitch, and if I'm going to shift to any other key, there's going to be a difference in the graph according to the pitch. So in this case, this is a combination of analog input, that is me pressing onto the key, to digital input, that is the sound signals being converted into the graph values, and a digital output, that is the difference in the graph itself. But we are going to be focused on the last two conversions, that is the digital sound signals being converted to digital output in the form of a graph. Okay, now that pretty much brings us to the end of this video. We will be looking more of these tutorials in the forthcoming sessions, but yeah, I can promise you that this is the principle that is behind the working of Arduino. We will be looking more of this in the forthcoming sessions, but until then, stay tuned. Have a good day.